Here are some questions that deal with radicals. First, when they say multiply and simplify. So one rule is when you're multiplying two radicals, you can all write it just within one radical and then multiply the two things that are underneath that. So I'm going to try that with this question. So it'll be the square root of 14m to the 5th times 7m to the 13th. Now, I can multiply the 14 times 7 if I want and get 98. And then the m's would be 5 and 13. I'm adding, multiplying common bases, add their exponents. That would be 18. And then I'm looking for two things inside that I can bring one out. So let me maybe rewrite this. 98, already I know it's 14 times 7. Let me rewrite it as 14 times 7. And then the m's, I'm going to have 18 m's, right? So since this is a square root, for every two things inside, I can bring one out. Okay, let me rewrite this just one more time, and then we'll start bringing stuff out. 14 is the same thing as 2 times 7 times 7. So 14 is 2 times 7, and then there's that other 7. And then you've got your m to the 18th. So here I have two 7's. I can bring one 7 out. Here I have 18 m's, so I can bring two at a time. I could bring out 9. And then underneath, I would just be left with a 2. So that would be multiplying those two radicals together and then simplifying. Similarly with this quotient one down here at the bottom, if I have two things in, I can bring one out. One rule that might help when you're looking at this is you could, with square roots, if I have the square root of a over b, I can rewrite that as the square root of a over the square root of b. And maybe I'll just do that with this. So on the top, I have the square root of something, over the bottom, square root of c squared. Now on the top here, I've got an a squared, and I have a b. And then this 150, let's see if I can break that down. 150, I think that's 25 times 6. And 25 is 5 times 5. 6 is 3 times 2. Let's write those in there. So 5 times 5 times 3 times 2. So here's two 5's. I can bring a 5 out. Here's two a's. I can bring one a out. And then on the top, that's sort of it. 3 times 2 times b. And then on the bottom, there's two c's. I can bring one out. So I think we're pretty good there. The only thing I would do is maybe in the square root, I'll multiply the 3 times 2 together. So I have 5a root 6b all over c. Okay? All right, here's another one. This one we're asked to add these radicals. You can't add radicals. The rule is if I have, say, 2 root b plus 3 root b, if the radicands are both the same, I can add or subtract their coefficients. So that would be 5 root b. If I have ones that are different, if I have 2 root b plus 3 root c, can't do anything because the radicands are different. So here, all my radicands are different. So I'm wondering maybe if I can simplify and get them to be the same. So let's do the same thing as we did on the last slide by breaking things down. So 5 root 8 is the same as 4 times 2, and 4 is 2 times 2. So this would be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Yep, that's good. And now let's just finish that one. So here's two 2's. I can cancel them and bring one out. So it'd be 5 times 2 root 2, or 10 root 2. So that's that one. Let's do this one. So that'd be 7. So there's a plus in here. 7 root 162, I think, is 81 times 2. Yeah. And 81 is 9 times 9, so I can bring 1 9 out. And inside I'd be left with a 2, 7 times 9, 63 root 2. You see where they're going with this question? So now I've got the same radicals, which is what I need. Next question, minus 7, and then 98, I think, is 49 times 2. Nice that they're picking numbers like 81 and 49 because you can take the square root of them. Square root of 49 is 7. I already have a 7 out there, so this would be another 7 times 7. And then underneath, all I have is a 2. Hey, same old. So 7 times 7 would be 49 root 2. Now I'll just add the coefficients because all the radicands are the same. So 10 plus 63 would be 73, and 73 take away 49. 73 take away 49. 4, 2, 24. So this would be 24 root 2. One last question. This is a tougher one where you have to solve this equation for x. To solve the equation, you need to isolate a radical. So both these radicals are on the same side of the equation. They're not isolated. So let's add root x plus 1 to this side. If I do that, I need to also add it to the right side of the equal sign. So it'd be root x plus 1. So I have root 2x plus 3 equals 1 plus root x plus 1. Okay, feeling pretty good there. Now I can square this side, and when I do that, the squaring cancels the square root. So on the left side, poof, no more square root. Yes. But if I square this side, I also have to square this side. If it's a binomial, that means I have to have 2 of these. 1 plus that. So there's 2 of them, and now I can FOIL those together. So 1 times 1 would be 1. 1 times this would be a plus root x plus 1. This times this would be a plus 1, or 1 root x plus 1. You don't need to put the 1 out front. You can if you want. Plus, the last thing will be the square root of this times this. So x plus 1 times x plus 1. And that's all equal to that. That looks a little messy. All right, let's see what happens then. So this would be a 1. These are the same, like the same radicands, so I can add and subtract their coefficients. So 1 plus 1 would be 2. So this would be plus 2 of those root x plus 1s. And then here I'm going to FOIL this together. So it'll be plus, no, I'm not going to FOIL it together, sorry. I can use the same principle as I did in the last slide. 2 identical things in, I can bring 1 out. So here's 2x plus 1s. So I can bring them out of the radical and just call it x plus 1. Equals 2x plus 3. Now I want to isolate that radical again. So I'm going to subtract an x. I'll subtract this one, and I'll subtract that one. So it'll be subtract an x here, and then I've got to subtract 1 and subtract 1. So on the right side, I'm left with 2 root x plus 1. On this side, this will just be an x. 3 take away 1 is 2. Take away 1 is 1, so plus 1. Phew. Okay, so now I have it down to just 1 radical left. There's a 2 here as well that bothers me a bit, but I can't divide by 2. Well, I could, but over here it would make fractions. So to me it makes more sense now just to square this side. And if I square that, I got to square this side. So if I FOIL this one here, it'll be x squared plus 1x plus 1x. That's 2x plus 1. You can check that if you want. And then on this side, if I square the 2, that gives me 4. If I square the square root, it just cancels that. So I'll be left with x plus 1. Right. Now, let's distribute that stuff on the right side. So it'll be 4x plus 4. Since this is a quadratic, I'll bring everything to the left side. So it'll be x squared plus 2x minus 4x. And then this would be minus 4, so that would be minus 3 equals 0. So x squared minus 2x minus 3 equals 0. I have a quadratic. Let's try factoring. Hope it works. X. I'm thinking minus 3 and plus 1 will work. Crossing my fingers. Let's continue on. So this would be either x minus 3 is 0 or x plus 1 is 0. So x is a 3 or x is equal to a negative 1. So those would be my answers. Now, important that you check these with radical equations. Let's just check them. So 3 and negative 1. Let's go back to my question up here. And I'm just going to mentally put a 3 in and see what happens. So let's use red. So I need to put a 3 in here, a 3 in there. Oh, let me rewrite the equation. I'm getting mixed up with the stuff that I did on it. So root 2x plus 3 minus root x plus 1 equals 1. So I'm wanting a 1 out of the deal. So I put a 3 here and a 3 there. So 2 times 3 is 8. 2 times 3 is 6. 6 plus 3 is 9. Square root of 9 is 3. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 does indeed equal 1. Yeah. So it's equal to 1. Therefore, 3 is an answer. 3, good. What was my other answer? Negative 1. Let's try negative 1. So instead of the 3 there, I'm going to put in a negative 1. And a negative 1. So 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. Okay, negative 1 plus 1 is 0. Square root of 0 you can do. It's equal to 0. And 1 take away 0 is 1. Yeah. So both the answers work then. So 3 works and negative 1 work. Those would be my answers. Hopefully that helps you with those radical questions.